Good morning, everyone. Am I audible? Hello? Hello?
Yes, ma'am.
Okay. Good. Whereas we were with this one. Yeah, I think we were discussing about this plate girders, the design of the plate girder, the problem we had taken this problem. Let's see. So we were doing this design of plate girders. Country girder was over. So on the plate girders, design of plate girders, we had calculated till the loadings. What were the loadings, etc. We had calculated these things. Yes or no? Then I think I with your section maybe yeah. This was the loading condition, and from here we have calculated our shear force bending moment diagrams. I told you find also. Okay. So these were the bending moment and shear forces, shear force and bending moment. Okay. I think we have done till here as much as I remember. So after that, what we are going to do, we are going to find out the section, selection of the section. So in the selection of the section, before that we had already now calculated the shear force and the bending moments. Now here we have to select a section for the plate girder. We know plate girder is a simple I section, right? So we know that our plate girder is in a simple I section which can be used anywhere with either with stiffeners or without stiffeners. Okay, but the gantry girder was used for what? For the loading, unloading in the crane system. This was used. Your gantry girders, okay, and your plate girder. This can be used anywhere for bridges, etc. Any kind of work. So you can use your plate girders. It's an I section, huge I sections. Okay, so here now after calculating the shear forces, we will now assume a section so that we can find out, we can design that how much the web size should be there and how much the flanges should be it, how much your size of flanges you should take. Okay, so we have a formula here which is optimum depth of the girder should be how much? Mk by Fy. Okay, I see you. This D is how much? This D equal to, we have D equal to is M, capital M, which is your bending moment, M, this one, yeah, fine, M into K divided by F Y, suffix Y, okay. So My to the power 0.33, okay, this is M, okay. Mk by Fy to the power 0.33. Okay, so now here M, we know M, we had calculated the moment. This is okay, the depth of the girder is given by M by K. This is M, okay. Wait, let me, this will go. This is M. So Mk by Fy 0.33. Now M, we know here, the moment we have calculated it is how much? This one. The maximum bending moment is 5976. Okay, so what we'll do, we will place the value of the moment here. M, K is what? Fy we know. Fy it is 250 for Fe410. We know it is 250. Now the thing which we need to know is our K to find out the optimum depth of the girder. So that is how much your K is given by D by TW. If I take you to IS code, this one, clause number 8.6.1.1, clause number 8.4. Okay, we need 8.6.1.1. You see here 8.6.1.1. Here the serviceability requirement, when your transverse stiffeners are not provided, okay, when your stiffeners are not provided in the I section, where on the web we sometimes need to give stiffeners, okay, like I, no, I cannot draw here, whatever. So suppose when we are not using or when we're not providing any stiffeners here, what happens? Your D by TW less than equal to 200 epsilon, okay, web connected to the flanges along both longitudinal edges. web connected to flanges along one longitudinal axis. Okay, this one we will consider here. So we have what if by d, if our d by tw, if this d by tw is greater than 200, that means intermediate stiffeners are required. This is required if it is greater than 200, your d by tw is greater than 200. But if your d by tw is less than your 200, which means that have an intermediate stiffeners are not required. Okay, so we will find out, we will assume, since we are finding out our depth, so we will assume that, we will assume for now this question that we are not providing any intermediate stiffeners. So when we are not providing intermediate stiffeners, interministerial, okay, when we're not providing not required one, what we have, what your d by tw should be, your d by tw should be less than 200. Okay, when your d by tw is less than 200, that means your web stiffeners, intermediate stiffeners are not required. You do not need to provide any stiffeners. So we will assume here now, for to find out the depth, or optimum depth of the girder, we will find out. For that we will assume it to be 150, which is less than 200. Okay, so we will have how much now? If you please uncalculate it, you will have your d, that is the effective depth, you will get it to be 1422.34 mm. Okay, so we can consider it to be 1400 mm for now, because this is the optimum value. So less than that also we can take. So now, after that, when we know now the overall depth of this, taking it to be 1400 mm, what will we again? We'll go to page number 63, clause number 6.8.6.1. So 63 8.6.1, this one. Okay, this was about this one, d by tw. This is 8.6.1. Now assume the thickness of the web to be 12 mm. Okay, we are assuming now, we will first of all assume the web thickness, web size. Okay, and then we will find out whether it is okay or not. Our the assumption of the sizes, the sizes which we are going to take, is that okay or not for the required, for the bending moment or the shear forces which are there after calculation which we have got. Okay. So we are assuming here now that our web thickness is 12 mm and the size of the, so therefore what will happen, we have our depth 1400, thickness we have assumed to be 1200. So our size of the web will be 1400 into 2 12. Okay, 1400 into 12. Now, bending moment is restricted by the flange only. Okay, one more thing to remember, that you have your, this are your webs and these are your flanges. Okay, these are your flanges and this is your web. So here, what will happen? This web generally, always your this web in an I section will always resist the shear, and this flanges will always resist what? It will resist all the moments. Okay, this will resist all the moments, this will resist all the shears. So now what will happen? See again one more thing, if I go to clause number 8.4.2, 8.4.2, 8.4.2, this one, we have considered our size, this is our size, this one, we have considered our size of the web to be 1400 into 12. So now you see here, resistance to shear buckling, resistance to shear buckling shall be verified as specified when d by tw is greater than 67 epsilon for a web without stiffeners and greater than 67 epsilon root over kb by 5.35 for a web with stiffeners. One moment. So you see here, we have assumed this, we have assumed this size. Now we will check one thing. which is your since your web is always resisting the shear, therefore resistance to shear buckling shall be verified. Okay, once it is verified, that means we will see whether it is okay or not. Like d by dw, if it is greater than 67 epsilon for a web without stiffener, it should be this much, greater than 67. Also, because before what we used to we have seen that our d by tw, if it is greater than 200, intermediate stiffeners are required. If it is less than 200, this one d by tw, it is not required. Now since for not required, when we are not using stiffeners, okay, we are not providing stiffeners, and the size we have assumed it to be now, after this calculation of the depth and the thickness, assuming the thickness, we know now this is the size of the web. Okay, this one size of this web is 12 and 1400. Okay, so now this one we also have to check here, since resistance to shear is given by your web, therefore resistance to shear buckling shall be verified, that it is we have done, like we have assumed it to be, we will not be providing stiffeners. So now we will look whether it is okay or not with our design. Like we have assumed the depth now after calculating the overall depth. Now this one we have assumed our d, and we have assumed our thickness of the web. Okay, so when we are assuming this thing d by tw, and we know, so we will see again, this will calculate how much was our d by tw. Our d by tw, we have not calculated this one. D by tw is how much? 1100, sorry, 116.66, which is greater than 67 epsilon. Therefore, resistance to shear buckling should be checked. See here, resistance to shear buckling should be verified as specified when your this much is greater than this much. So we will see here through this, that through this clause we will see whether we need to check for shear or not for this particular web size which we have considered. Now we have considered this website, we will check now whether it is your shear resistance or check for shear is required or not, and that we are going to check by clause number 8.4.2 here by this. For since we are using with the, we have taken without stiffeners the web, therefore this formula, if it is greater than 6 points, if d by tw is greater than 67 epsilon, we will have to check for shear buckling of the web is required. Check for the shear buckling of the web is required. Okay. And if it is, if you have provided stiffeners, your d by tw should be greater than this value. Okay, now bending moment, this bending moment is taken by the flange, we know. Okay, we know that our flange takes the bending moment, so resists the bending moment. So we know the area of the flange is given by m gamma m o. This is gamma m o. Okay. M gamma m o fy into d. Now, if you see here, this was AF is equal to M gamma M. If I say you here M gamma MO, MO divided by FY by D. This is gamma MO. Okay, this is D. So we have what M is, we know we have already calculated the M. This was how much? 5976. So we know our moment. We know our moment gamma mo, we know from table 5 again. Fy we know it is 250. Our d we have just assumed to be for 1400. This one the overall that the 1400 it can be. So this one 1.10 was our gamma mo from table 5. We'll have this thing Fy, you know, d, you know, So we got our area of the flange is to be dismissed. That means we require a flange whose area should be 18781.71 mm square. Okay, so according to this requirement of the area of the flange, we are going to check now and design for the flange what can be the sizes of the flange. So when we for compression flanges with welded section, IS code, if we go to this IS code, here if 18 no, if we go to I don't know, 18, if you see here, if you have a welded section for the compression element, since your um, this thing na, compression element here, which is a welded section, B by TF is how much given for a plastic section. We have assumed that our section is plastic, it has to be, so it should be 8.4 epsilon. So you see here, this one, for compression flange with welded section, we have B by TF is equal to 8.4 epsilon for, sorry, plastic section. This one, from this table to page number 18, we will get for welded section. It is how much? 8.4 epsilon. B by TF is equal to 8.4 epsilon. Now from here, if we see from here, B by TF is equal to 8.4 epsilon. So B will come out from here. We can see B is equal to 8.4 epsilon TF. Okay, 8.4 epsilon TF. Now, if you see this figure here, there are different types of flanges, and you see here whether it is roll, beam, uncolumn section, or roll journals, whatever. Your B, when it is an I section, your B is how much? B is denoted by your B, which is denoted is this portion, half of the flange from the mid of the web. Okay, 1 minute. Arrow, how goes on? So this is how much? This is B from the web of the center of the web of the this thing I section. Okay, so here what we have seen here, we have got this value, B is equal to 8.4 epsilon into TF. So here it is B, this portion is B. So B is this much, 8.4 epsilon TF. So if you multiply it by G, obviously you will get this dimension, the width of the flange you are going to get. Okay, now one more thing again, area of the flange, we know how much. Area of the flange will be how much? This BF into TF. This is your TF. This is your TF. This is your TF and this is your B. So we have how much now? Area of the flange will be this into this. So we know now area of the flange is how much? We had a required area, right? This one, area of the flange we had calculated, which was required area. So 18781 here. And the width of the flange in TF. Obviously the width of the flange, this one, BF, suffix F, is how much? Twice of this B. So nothing but 2B into TF. So now what is your B? B again we know from here it was 8.4 epsilon into TF. So from here we can find out easily our TF will get. So TF we have got it to be 33.43 mm, but we can consider it to be 40 mm. Okay, so now we have got our thickness of the flange to be 40 mm. Okay, and we have this width of the flange we have to calculate, right? Now to find out this width of the flange, what we'll do now, to calculate this width of the flange, what you will do, width of the flange here, from here if you see, this one is AF by TF. So AF is how much? Area was 1871, this one 18781, and we have the thickness of the flange to be 40 mm. So we have got our width of the flange to be almost, we can consider it to be 500 mm. Okay, so now we got our size of the flange. We can consider our size of the flange, which is 500 into 40. 40 is the thickness, and we have the flange width 500. তাকে বহা না লাগে বেলেগ লৈছো So we have how much? We have got our size of the flange to be 500 into 40. Okay. So this is our size of the flange. Now we will check whether the size we have assumed or we have calculated after assuming the things. So this will be from this we are going to check serviceability check from page number 63 of IS code. Page number 63. Page number 63. So page number 63, if we go to page number 63, you see here clause number 8.6.1.1 here. Now you'll see here this clause number 8.6.1a. Here, when transverse stiffeners are not provided, and in our question we have not provided transverse stiffeners. Okay, so D by TW should be less than equal to 200 epsilon, and that we have already calculated. So now we'll also check from here, we can check, because when we were finding out then the overall depth, that's why what we have done, we had to know the overall depth. To find out the overall depth we had to find out D by TW, and so D by TW was how much? D by TW we had assumed it such that because we have considered it to be, we have not used any stiffeners, but here we are going to check whether it is okay or not. Okay, our D and TW, whether it is okay or not. How? When we are not providing our stiffeners, D by TW should be less than 200 epsilon, and that is here we have checked here serviceability check. D by TW is 116.66, 200 epsilon. 1 minute, huh? Excuse me. Hello, I'm sorry, I forgot to unmute it. Am I audible? Hello.
Yes, ma'am.
Yes, ma'am. Audible, ma'am.
Okay, okay, okay. I forgot to unmute myself. Sorry. So, I think I left here. Yeah. Serviceability check. We were doing the serviceability check here. So, where was the clause? Yeah, this one. For the serviceability check, we have done for the web serviceability here. If transverse stiffeners are not provided, what we are going to do, we have to, this should be satisfied. D by TW should be less than or equal to 200 epsilon. And so we have seen our here, it is less than 200 epsilon. So it is okay. Okay. Now next check which we are going to do is our compression flange buckling requirement, which is here in page number 64. 8.6 point this this one. Compression flange buckling requirement. In order to avoid buckling of the compression flange into the web stiffener, the web thickness shall satisfy the following. We had assumed a web thickness right at the beginning, so whether that is okay or not now for this, such that it can avoid the buckling of the compression flange. Okay, so that thickness can avoid the buckling of the compression flange. So uh, this has to be checked. So here what we are going to do when transverse stiffeners are not provided, and we, this is for provided, but we have not provided now in this question. So this is wait, compression flange buckling requirement, D by TW. Yeah. Yeah. This one, when transverse stiffeners are not provided, this is when provided. But in our question, we have not provided stiffeners. So that means D by TW shall be less than or equal to your 345 epsilon F square. Okay. Epsilon F is nothing but the, this one, yield stress ratio of web, which is root over 250 by Fy. Okay. So now, if we see here, this one, d by dw was how much? 116.67. We had calculated this, and this is also less than our 345 epsilon f square. And epsilon f square is our one. We know that epsilon f is what? 250 by Fy, which is our yield stress, and our yield stress is how much? 250. This one, 250. Obviously for Fe410 we have Fy to be 250, so this comes to be 1. So that therefore that means what? This d by tw should be, sorry, this d by tw should be less than equal to 345 epsilon square. Epsilon square is nothing but 1 right here. So d by tw should be less than 345. So less than 345, yes, it is less than 345. So therefore the minimum thickness of the web 12 provided is sufficient. Okay, which we had provided here at the beginning. Here we had assumed this one, the thickness of the web we had assumed to be 12 and so we have checked here that it is okay, that this one here web is 12 which is we minimum 12 which we have considered is okay and sufficient for the design purpose. Now if we see the next check, if we see, it is a check for the moment capacity here, table 2, page number 18. We go to page number 18, 12. This one, page number 18, 12. Meeting is going to end in 5 minutes. Okay, this step will be in the next class. Let me take your attendance till then for today's first class here now. Roll number 1, Stephanie. Please give me your attendance now here.
Roll number 1, present.
Okay, 27. Roll number 1 present. 2, 4,
Present, ma'am.
5,
Bye, ma'am.
6.
Present, ma'am.
Please tell,
Present.
okay, please tell your enrollments. Okay, 6.
Present, ma'am. 6.
Okay, 7, 8, 9, 10, 11, 12, 13,
Present, ma'am. 012.
okay, 14, 15,
14 present, ma'am.
okay, 15,
15 present, ma'am.
16,
Present, ma'am.
17, okay, 17,
Yes, ma'am. Yes, ma'am.
18,
Yes, ma'am. 18.
okay, 19, 20,
Present,
21,
ma'am. 20.
20, 21, 23, 24, 25, 26, 30,
26 present, ma'am. 26.
30, 31, 32, 34, 36, 37, 38,
Present, ma'am.
38,
37.
37, 38, okay,
38.
39, 39, 40, 41, 42, 43, 40,
43 present, ma'am.
45,
45 present, ma'am.
okay, 48, 49,
49 present, ma'am.
27, 10, okay, 50, hello, 50, 51, 52,
Ma'am, 51 present.
51, 52, 54, 54,
54.
54, okay, 57, Abdul
Yes,
Latif,
ma'am.
57,
Present.
okay, 58,
Yes, ma'am.
58, 58, 60, 61, 63, 99,
Yes, ma'am. 63.
99,
63.
Yes, ma'am.
Yes,
99.
ma'am.
yeah, 63 present, 101,
Yes, ma'am.
104, 106, 108, 109,
109 present, ma'am.
okay, triple one,
Present, ma'am. 111.
okay, 113,
Present, ma'am. 113.
114, 118, 120, 1,
Present, ma'am.
Present, ma'am. 120.
okay, 124, 133,
124.
okay,
Present,
okay,
ma'am.
133, 134, 136,
134. 134 present.
136, 143, 144,
143 present, ma'am.
okay, 144,
143 present, ma'am.
okay, 144, 155, 149,
145.
149, okay,
145.
149, 151, done. 151, 149, absent. Anyone left? Any left, I think. Roll number 7, absents are 7, 8, 9, 10, 11, 19, 21, 22.